Welcome to an Achieving Science video. This video is going to look at the conservation of mass. Now this is an important law that you need to be aware of, so the law of conservation of mass. So in a chemical reaction we have reactants. These reactants form products, and this can be represented via a word equation. Now the law of conservation of mass states that no atoms are lost or made during a chemical reaction. Therefore, the mass of the products must equal that of the mass of the reactants. So what you have before, you must have afterwards, and be able to account for it. We therefore used balanced equations. This means that chemical reactions can be represented by symbol equations, which are balanced. They're balanced in terms of the number of atoms of each element involved on both sides of the equation, so therefore the reactants and the products. Let's use an example then. So in an example of a chemical reaction, we can have carbon reacting with oxygen to produce carbon dioxide. And we can write this as a word equation, where the reactants go on the left-hand side, separated by an arrow, and the products go on the right hand side. In this case there is only one product, and that is carbon dioxide. We can also represent this then via a symbol equation. Using the symbols of the elements from the periodic table, we find that carbon has the symbol C, oxygen goes around as a diatomic molecule, which means it goes around as a pair, so O2, and it produces CO2. We can look at this if this is balanced. So if we look at the number of atoms before, so we have one carbon atom and two oxygen atoms, and we look at what we have produced after the reaction, we have one carbon atom and two oxygen atoms. We can see whether this is balanced or not. In this case, the equation is balanced, as there is the same number of atoms before and after. Let's now look at another example then. Let's look at the reaction of forming water. So first of all, let's begin like we did with a word equation first of all. So water is H2O, so made up of hydrogen and oxygen. And therefore a word equation would be hydrogen reacting with oxygen to produce water. Again, let's then convert this into a symbol equation. Like oxygen, hydrogen is a diatomic molecule, so H2. It reacts with oxygen, O2, to produce water, H2O. Again, let's then work out what atoms we have before and have afterwards. So before the reaction there are two hydrogen atoms, and we draw this as a molecule where two hydrogen atoms are joined together, making H2. We also have two oxygen atoms. Again, this is formed by two oxygen atoms joined together. And then after the reaction, we have H2O. So there are two hydrogen atoms and only one oxygen atom. And again, we can draw this as a molecule. We see that there are two hydrogen atoms joined to an oxygen atom. Now we cannot add another oxygen to this water molecule because it will no longer be water. So instead, the solution to get more oxygen into the side of the products is to add and create another molecule of water. So if we draw out another molecule of water, we can now see that we have 4 hydrogen atoms and 2 oxygen atoms. Now if we compare this to what we have before, we are now short. Because we are now short of hydrogen. Because we only begin with 2 hydrogen atoms but yet have 4 in our products. And therefore we need to produce or use another hydrogen molecule. So we can draw this in again. So 2 hydrogen atoms joined together. We now can see that this is balanced, and what we have before we have afterwards. And we can summarise this as a balanced symbol equation. So we have 2 molecules of H2, a single molecule of O2, so we don't need the number 1 in front of it. And we produce 2 molecules of H2O.